Now, scientists are hailing a major discovery, a new planet which they've called Proxima B. At just 4 light years away, it's relatively close to us. It's roughly the same size as Earth, and because it's just the right distance away from its star, it could be the right temperature to have liquid water and possibly life.
When the James Webb Space Telescope released its first ever real image of Proxima B, the astronomical community, and indeed much of the world, paused in awe. After years of speculation, anticipation, and groundbreaking technological progress, humanity was finally able to look directly at a world orbiting the nearest star to our own solar system. Proxima B, a rocky exoplanet nestled in the habitable zone of Proxima Centauri, had long been a source of fascination for scientists and the public alike. But until this moment, it had been a subject of indirect observation, its existence inferred through subtle wobbles in its host star's movement, its mass estimated through spectroscopy, its potential climate debated with fevered passion across scientific journals. Now, for the first time, there was an actual image, not an artist's rendition, not a simulation, but a photograph captured with humanity's most powerful eye in the sky. Before we start, smash the like and subscribe buttons for more updates. The image, delivered in incredible detail, showed the dimly lit silhouette of Proxima B bathed in the faint glow of its red dwarf sun. Webb's sophisticated instruments, particularly its near-infrared camera NIRCam and mid-infrared instrument MIRI, worked in tandem to peel away layers of cosmic dust and glare that had made such a glimpse impossible until now. What emerged from the depths of space was not only a testament to engineering brilliance, but a moment of existential gravity. For generations, the stars had been abstract backdrops, points of light scattered across the sky. Now, one of those distant lights had transformed into a world, visible and real. Proxima B's image revealed a textured surface with variegated light patterns, suggestive of continents or geological formations. While the resolution was not fine enough to discern individual structures or detailed topography, the data hinted at the presence of distinct landmasses and potentially large bodies of liquid, though whether these were oceans, lakes, or frozen plains remained speculative. The planet's albedo, or reflectivity, was measured more precisely than ever before, offering clues about its atmospheric composition. There appeared to be evidence of a thin atmosphere, likely composed of carbon dioxide or nitrogen, though possibly laced with water vapor, an indication that Proxima B might not only be rocky, but also in some sense Earth-like. This moment was more than a technical achievement. It was an emotional and philosophical breakthrough. Seeing Proxima B stirred a primal response. The mere act of visual confirmation bridged the chasm between numbers and reality, between the hypothetical and the tangible. Until now, Proxima B had existed in equations, in data streams, in the imagination. Now, it existed in light, photons that had traveled over 4 years through the cold vacuum of space to be captured, filtered, and rendered into an image by the Webb telescope's sprawling mirrors and detectors. Scientists were quick to contextualize the event within the larger arc of human exploration. For the first time, a rocky exoplanet within the habitable zone was not just a blip on a graph or a concept for science fiction, but a real visible place. This breakthrough rekindled discussions about the probability of life beyond Earth. The fact that Proxima B lies within the Goldilocks zone, where temperatures might allow for liquid water, has always tantalized researchers. With this new image, those discussions took on renewed urgency and depth. While the telescope could not yet capture signs of life, such as biosignatures like methane or ozone in the atmosphere, it laid the groundwork for future observations that might. The technology behind the James Webb Telescope played a central role in this moment. Webb's ability to block out the overwhelming glare of Proxima Centauri, a red dwarf star, using its coronagraph and other light-dampening techniques, was nothing short of miraculous. Its capacity to see in the infrared spectrum allowed it to penetrate the dusty shrouds and stellar interference that had previously rendered Proxima B invisible to earlier instruments. The image took weeks of data compilation, photon integration, and processing, yet the result felt immediate and visceral. It was as if Webb had reached across the void and touched another world. What captured the public imagination most was the very familiarity of what Webb showed. Despite being alien and impossibly distant, Proxima B looked like a world that could be real to us. Its round, shadowed form glowed with a muted reflection that recalled our own moon, or the distant, haunting haunting images of Mars taken by early orbiters. There was a surface, there were contours, there was the implication of change, of weather, of geological history. People looked at the image and felt a sense of eerie kinship, not because Proxima B is hospitable or even hospitable adjacent, but because it now occupied the realm of the seen. Astronomers had long predicted that direct imaging of exoplanets would revolutionize how we think about the cosmos, and they were right. Seeing Proxima B shifted the planet from a data point in a catalog of thousands to a place, concrete, complex, and physically real. Researchers began to speculate anew about its rotation, its orbit, the intensity of radiation from its parent star, and how all these factors might affect its potential to harbor life. Unlike Earth, which enjoys the relative stability of a G-type main sequence star, Proxima B is likely tidally locked to its red dwarf sun, meaning one side may perpetually face the star while the other lies in constant night. This raises intriguing possibilities about life and climate. Could a habitable twilight ring exist between the scorching day side and the frozen dark side? Could cloud patterns and ocean currents, if they exist, mediate these extreme conditions? While Webb's image does not answer these questions, it provides a solid foundation for framing them. Spectrographic analysis that accompanies the image is already being parsed for chemical signatures. Astrobiologists are examining the data for telltale signs of atmospheric disequilibrium, conditions that could point to biological processes. Meanwhile, geologists are theorizing about the planet's composition and internal heat sources. The idea that tectonic activity or volcanic outgassing might sustain a dynamic environment is being explored anew. The release of the image marked not only a scientific triumph but a cultural milestone. Proxima B, once the domain of research papers and speculative fiction, now had an identity in the human visual lexicon. It joined the pantheon of iconic space imagery, alongside Earthrise, the pale blue dot, and the deep fields of Hubble. But perhaps it was even more profound. Unlike those images, which captured objects we already knew in poetic relief, Proxima B represented the discovery of the unfamiliar made familiar. It was a place we had never seen before and yet somehow recognized. The implications for the future of space exploration are monumental. With Proxima B now visible, mission planners and private space firms are re-evaluating long-term goals. The idea of sending probes, even relativistic light sails like those proposed by the Breakthrough Starshot Initiative, has gained new traction. If a world can be seen, then it can be reached. Not today, not in a decade, but perhaps within a century. This one image, so deceptively simple in appearance, redefined what proximity means in cosmic terms. 4 light years away is no longer the abstract, unapproachable distance it once seemed. Now, it is a neighbor's doorstep, albeit one that requires extraordinary effort to reach. The emotional weight of the event cannot be overstated. For many, the image triggered a sense of existential reflection. If such a world exists so close to our own, how many more lie beyond? Webb's image of Proxima B served as a lens not just into another planetary system, but into ourselves, into the aspirations, curiosities, and audacities of a species reaching beyond its cradle. The cosmos suddenly felt fuller, more populated, more intricate, and in that fullness was a reassurance that the universe may not be a vast and empty stage, but a dynamic arena teeming with stories yet untold. In academic circles, the announcement set off a wave of new proposals and collaborative efforts. Universities, observatories, and space agencies around the globe convened emergency panels and roundtables. What do we prioritize next? What instruments should we train on Proxima B? Can upcoming missions like the extremely large telescope ELT or LUVOIR build on this achievement? Scientists discussed launching coordinated campaigns to monitor the planet's atmosphere over time, to detect any variations that might signal seasonal changes or transient events like dust storms or volcanic eruptions. The image also ignited a broader conversation about our role in the galaxy. If Earth is not unique in its ability to support complex geology, climate, and potentially life, then the imperative to preserve our own biosphere becomes even more profound. The sight of another world so close, so real, reinforced both the rarity and the fragility of our own. It also deepened the sense of cosmic camaraderie. Even if we never visit Proxima B, even if no life exists there, its presence enriches our understanding of planetary diversity and the potential trajectories for worlds other than our own. Proxima B's image is destined to be studied for decades. Future technologies will build upon it, refining our view pixel by pixel, spectrum by spectrum. But the first image, the one captured by Webb, will always hold a singular place in history. It is the photograph that turned a hypothesis into a landscape, a calculation into a destination, and in doing so, it brought humanity one step closer to fulfilling one of its oldest dreams, to know the universe not just by measure, but by sight. As telescopes become ever more sophisticated and missions more ambitious, the vision of exploring and understanding other worlds grows sharper. The direct imaging of Proxima B marks not the end of a journey, but the start of an era, one where stars are no longer remote, untouchable objects, but gateways to new frontiers, one where seeing is believing and believing becomes a blueprint for action. Webb's photograph is more than a snapshot. It is an invitation, and it is one we are more prepared than ever to accept. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Proxima B's image by James Webb Telescope? We want to hear from you. Thank you for watching, and see you next time.